Good afternoon, everyone. It is time for us to get started with today's webinar, and we're going to be looking at network troubleshooting basics today. I had somewhat of an issue getting my slides to upload to WebEx and display. For some reason, it was just giving me a white screen, so we'll share the desktop and just continue from that perspective. Now, what I'd like is if you could, in the chat box, very briefly, before we get things rolling, simply let me know you can hear me. If some of you say that you can, then that will mean that the audio is working and I can go ahead and continue with the presentation. So again, if you can simply chat in, let me know that you can hear me, that would be great. All right, excellent. I see at least one, so I know it's going from me. If that's the way it's working, then I know that we've got that part functioning appropriately. Okay, so we're going to go ahead and get started with today's webinar, and the topic again is network troubleshooting basics. Now, the important thing about network troubleshooting is that there are some fundamentals that you need to know in order to effectively troubleshoot any network, whether it's a wireless or a wired network. And so today we're going to talk briefly about the troubleshooting process, and we'll also add in some extra information about thinking through some models for troubleshooting related to capability. We'll then look at using a protocol analyzer, some command prompt tools, and even the Windows GUI tools that sometimes people aren't aware can be utilized for wireless LAN troubleshooting. Again, we'll keep our time together to around 30 minutes or so as we study network troubleshooting. This is a very important foundational topic for those studying for the CWAP examination, and also for those that just have to work with their CWNA knowledge every day in the networking arena. Now, the first thing then to talk about is the process. The process of troubleshooting is also called a methodology or a system that you use to troubleshoot. So it's important to have this kind of a process down. Now, here at CWMP, we recommend this 8-step process, but you will find methodologies that are suggested by Cisco and HP and Microsoft and many other organizations out there that have developed their own steps that are usually very similar to this. The first step is identifying the problem. We don't want to just jump in and start trying things. We want to make sure that we're actually dealing with the appropriate problem, because it's very possible that you could get a problem complaint from a user, for example, and when you actually begin to identify the problem, you find out that their complaint was not completely accurate. In other words, it's not uncommon, as I've said in other presentations, to have a user tell you the wireless LAN's not working, but then when you actually evaluate it, it turns out the wireless LAN's working just fine, that there's a wired networking problem or something like that. So the point is that we need to first identify the problem. Then we need to discover the scale of the problem. In other words, is this impacting one user or every user in a basic service set? Or for that matter, is it impacting every user on every access point in the organization? So what is the scale of the problem? Because that's going to help you narrow down whether it's a client-side issue, a BSS issue, or possibly a controller issue or central management issue. So it's important to know who's being impacted. Third, now that we know the problem and the scale of the problem, we can define the possible causes. So given what's occurring, what are some of the likely causes? And then we can narrow all of those down to the most likely cause. Now this we get better at over the years. And the reason is, as you build expertise, you're more able to seemingly intuit the cause of a problem. You're not really using intuition, you're using expert knowledge, but you can quickly get to the most likely cause of the problem because you've experienced the various problems so many times, and you're looking at, say, a pool of 7 symptoms that are occurring, and you know every time you've seen those 7 symptoms, it's been a particular problem. So you can drill down to that problem very, very quickly. The next thing is to create a plan of action or escalate the problem. Now, many troubleshooting methodologies simply say create a plan of action. The reason we add or escalate the problem is very simple. You may not be the individual who can resolve the issue. It's not unusual, for example, for someone to work at a location in a company as the networking expert there, but the actual access points may be controlled by controllers across a WAN link or something of that sort, and you may not have any access to those controllers. So you might have to escalate the problem to someone who does. So when you've determined the likely cause, You can then either deal with it yourself or you can escalate it to another person who can. And then we're going to perform corrective actions, one at a time. We're going to try to solve the problem by making a change, updating firmware, installing device drivers, reconfiguring IP, doing whatever it is that we feel will correct the problem, and then checking to see if it did solve the problem. What we don't want to do is say, well, there are 7 things that could cause the problem. I'm going to change all 7 things and see if it's resolved. Because you may actually cause more problems by doing that. You only want to make necessary changes to resolve issues. So then you'll verify the solution, but you're not done. Sadly, in many environments, people are done at step 7. They don't document the results. But documenting the results is tremendously valuable both to you and to other people that are helping you in the troubleshooting process. It's beneficial to you because in the very act of documenting, you are embedding this knowledge better in your own storage, in your brain, right? So you are storing it better by documenting it than you are just by experiencing it. Also, you're increasing your explanatory capabilities. In other words, you're learning to better explain the scenario of the problem as you document it. Yes, it takes time to do, but those 2 benefits are valuable in and of themselves. The fact that you're more likely to remember it and the fact that your explanatory abilities are being expanded. But in addition to that, maybe this problem occurs again 7 months later. And even though you did document it then, it's not ingrained in you because it's only happened once. When you go back and search your documentation of past problems, the answer will be there. Now that leads us to why it benefits other people. You always hear people talk about how to make money in life by using OPM, right? Other people's money. Well, what about OPK? Other people's knowledge. In other words, if you're documenting and your peers are documenting, this is going to build up a knowledge base of great value specific to your organization. And the reason that's important is you're probably going to run into problems in your organization that no one else experiences. It's unlikely that any other organization has the exact same set of devices and configurations that you're using. So you may run into problems that no one else has seen. Your internal documentation will help you resolve those issues again in the future. So documentation is absolutely key. All right, I've said enough. I'll leave that one alone and we'll move on. But as you can see, I'm passionate about documenting what you've learned. Now let's talk about this concept of capability. I've talked about it in other webinars, and it's a concept that I really like to focus on in relation to wireless LANs. It's not just about coverage, and it's not just about capacity. It's about capability. And so if I build a wireless LAN with coverage and capacity, great, they can get a lot of data through the pipe. But can they do what they need to do? That's function. Are they actually able to perform what they need to perform? And that usually comes down to network services being made available to them to do their work. And scale, while some might suggest it's part of capacity, I like to see it as something a little bit different than capacity. Because capacity is what I have right now. Scale is, do I have the ability to grow and get more capacity? Is it scalable? Can I add more access points? Are my controllers already saturated? Would I need more controllers? These are the kinds of things we think about when we think of scale. So why do I bring this up when we're talking about troubleshooting? Well, I bring it up because what you're actually troubleshooting is the user's capability to do what they need to do. That's what you're always troubleshooting. You're never really troubleshooting connecting to the network. You're never really troubleshooting, I can get on the network, but I can't access this particular application server in the company. Yes, that might be the specific thing, but what you're doing is finding out why the user can't do what they need to do. And this comes down to one of the 3 areas other than scale here in most cases: coverage, capacity, and function. Do they have a signal so that they can connect? When they do connect, do they have the throughput that's required? And do they have the functionality they need once they connect? So you're really troubleshooting the issue that the user doesn't have the capability to do what they need to do. And it can fall into any of these areas. It can be a coverage issue, it can be a capacity issue, it can be a function issue. The scale is more about long-term planning and design scenarios. But the point is that this is what we're going to be doing when we actually troubleshoot our networks. Okay, enough foundational information. What we're going to do now is actually look at a demonstration. And In this demonstration, I'm going to show you a few things. It's going to be a very impromptu demonstration. I do not have pre-recorded videos that are going to show you these things. I don't have specific step-by-step instructions in front of me. We're going to use these tools like people use these tools. And so what we're going to do is take a look at Protocol Analyzer. We'll look in this case at CommView for Wi-Fi, simply because I have an adapter that works with it available to me here in the studio where I'm doing the webinar. We're going to take a look at some command prompt tools, some that maybe you haven't seen, some that you have, and we'll also look a little bit at the Windows GUI. So remember, this is network troubleshooting basics, so we're not going to go into tremendous depth, and we'll not be looking necessarily at advanced tools today, but some tools that are very useful in this troubleshooting process. Now, the first thing we want to do then is launch CommView for Wi-Fi and take a look at the options available for us there. Let me note as I'm loading CommView for Wi-Fi that this presentation is being recorded. So if you happen to be on a screen right now where it's really compressed because I am recording in 1080p, then just know that you can take advantage of the fact that it will be at the YouTube channel, CWNP-TV, when we're done. So you'll be able to go out there and take a look at the recording of this in high resolution at any time later on. Okay, so here we are in CommView for Wi-Fi. This is a protocol analyzer. Protocol analyzers are very useful, obviously, for troubleshooting communication problems on networks. Now, the first thing you'll notice when we get in here to CommView for Wi-Fi is that it has integrated into it spectrum analysis. Now, this is actually using the MetaGeek WiSpy DBX adapter is what's actually being used here. So if you have that adapter as well as an adapter that works with CommView for Wi-Fi, then you will be able to see the spectrum information that we're seeing here. And of course, as is absolutely typical, you can see the 2.4 gigahertz frequency bands are flooded. There's a lot of stuff going on there. And the 5 gigahertz is not quite as busy, so we can see that. So the 2.4 gigahertz is what we see in the top half of the spectrum analysis here, and 5 gigahertz is what we see in the bottom half. Not nearly as busy as the top half, at least right now. Now, I can make that busy in that I am connected to the wireless network that we see there. And as you can see, as I begin to transmit some video using my iPhone 6s, it is beginning to show more activity in the 5 gigahertz spectrum, but it's still not as saturated as 2.4 gigahertz. So we can see this information rather readily and quickly, and that is useful for troubleshooting in and of itself, just activity in the spectrum. But this is a protocol analyzer, so it can show us a lot more information. The first thing I'm going to do is use it in scanner mode. And so you can see here to the right, the scanner mode options. I can scan all 11 channels that are used here in the US where I'm presenting, and I can choose the 5 gigahertz channels I want to scan. I can also choose how long to rest on a channel. So I'm going to change that. I'm going to lower that down to, instead of a full second, 0.8 of a second, so that it'll scan the channels a little faster. Do find if you set this too low, you may not find all of the APs for a very long period of time, simply because it may jump off channel before the AP happens to send a beacon frame that it captures. So it's very useful to stay on channel a little longer. I've had good luck with as low as 0.5, but if you go too low, you'll find it's having a difficult time finding some of those access points. So with that set, we can come up and just click the Start Capture button. And as soon as we begin to capture, notice that down in the spectrum analysis section, things begin to change. We start to see our different wireless LANs specified in the area where they're actually operating. So what you can see here is immediately it's beginning to enhance even the spectrum view. Now you'll also notice that down below in the 5 gigahertz, I'm starting to see the different 5 gigahertz networks that are there as well. So in the top, we have the individual list of all the networks that it's finding. And so we can see the difference between an AP and a client, in that an AP has the little logo that has the RF radiating up and out, and the clients are shown below the AP to which they're actually connected. Now, it's important to note that most of these networks have nothing to do with me. And you will find when you're scanning like this all kinds of oddly named networks, some quite offensive, frankly. But this is what you get when you're doing protocol analysis, everything that's in the area. Now, I happen to be very near an apartment complex, and so in fact, I'm getting a lot of oddly named SSIDs. But down here below, you'll see one that I'm running. It's named Office 5, and you can actually see it is a Belkin device. It's actually a Linksys 802.11ac access point. And if you look down below, it's kind of a shaded purple, so it's hard to see. But Office 5 is right here, and you can see it is indeed using 20, 40, 60, 80, and 80 megahertz channel for its communication. So it's an 80 megahertz SSID that is operating. So we've got that information. And if some communications are taking place, eventually you'll also be able to see the clients that might be connecting. Now, that client would probably need to be doing some communicating during the scan of the channels in order for it to show up. Otherwise, the client's not going to, because it's not sending out beacon frames periodically, right? So for it to show up, you have to actually be able to capture the information that that particular client is communicating so that it will actually show up in the display. Now, I happen to be connected to that particular access point at this point in time, and it's still not finding it because of the fact that we're only dwelling for a few hundred milliseconds on the actual channel. So what I'm going to do now that we've seen that is I'm going to stop this, and let's take a look at some of the information that we can see. Then we'll scan just on the channel that we're on. So when I go into channels, and I scroll down to channel 149, which happens to be the one that that particular Office 5 SSID is running on, we can see that we've had some data sent at 702 megabits per second, 244 megabits per second, 585 and 65, and 11 N rates, a few. The vast majority of communications are going out at 24 megabits per second, and then a lot at 6 megabits per second. Now, you're always going to see a lot at 6 megabits per second. I'd like you to pause and think about why that might be, and then I'll give you the answer. Okay, well, that's long enough of a pause. The reason is that's the lowest data rate that's supported in the BSS. And your various management and control frames are often going to be sent at that rate. Not all control frames have to be, but management frames such as the beacon frame will be, so that every station that could possibly be connected can receive that beacon frame. So you're seeing those beacon frames going out at that 6 megabit per second data rate for that reason. And in fact, if we go over here to our packets, we can actually take a look while going through the packets, see if we can find some frames that might reveal some information to us here. You'll notice that we've got a lot of control frames. Those are going at 6 megabits per second. We can see that right over here. So this is a good example. This happens to be an RTS, so it's type 1, subtype 11 in the frame control subfield of the frame header, and therefore we have an RTS frame right here. Immediately following it, as we would hope to see, is a clear to send frame. You will notice specific information here, like the duration value, 276 microseconds, and then 216 microseconds. Well, the CTS is going to be shorter than the RTS because the RTS duration had to include the ensuing CTS. The CTS must only include the ensuing data that is to be communicated. And so it does not require that it have the same length. You'll notice that we've got encrypted data, so it's going to look like gobbledygook to us, and we're going to be unable to see the actual data, but we can see the frame header information, and this particular data frame, if we look over here to the left, we can see was transmitted at 520 megabits per second. We can further see the destination address and the source address. The source address here is B4750E, and if we go back to our nodes over here, if the node was displaying for the actual iPhone device that was connected, we would see that that's the MAC address for that device. So we can actually see quite a bit of information just in this way, but let's go ahead and change to a single channel scan mode and scan our channel 149, which is the one that the Linksys AP is on. And I'm going to come up here and clear my nodes and my channels and my packet buffer. And let's start scanning again. So here we're just scanning on that one channel. So we're not going to get all of the extra AP information at the bottom that we had before. But we can still see the information that is being communicated. And you'll notice that now, because we're just on that channel, as I said, we're seeing the Apple device right here that is now displayed. And it happens to be playing a YouTube video, by the way, just in case you're interested. So I'm playing a YouTube video with the sound off in order to be able to have some traffic generated from this particular device. Also, you should note that while you're seeing a really good signal strength of neg 75 here, well, the important thing to note, neg 40 actually, the important thing to note is that I'm in the room with the access point, so it's very close to me here. If we double click on the actual device, we can see the packet types that are being sent. Really good information here, right? Our retry rate is well under 1%, such that it's reporting it as 0% because we've sent 30,000 packets and only 14 have been retries. We'll look at that again when we look at the actual channel. There are more retries in the channel than there are from this station, because this has to do with this station performing retries. If we look at data rates, we can actually see this station has sent some things as high as 780 megabits per second, and that is a byte transmitted from the client up to the AP. We can see 134 megabits per second used both receiving and sending. Right here, notice receiving and sending or transmitting. We see a lot at 24 megabits per second, and we see a few here at 585 megabits per second as well. So that's looking at the actual station. We can expand here and see the signal level in dBm riding right around neg 40, which is a really good signal and why I'm able to actually at times communicate at some of these higher data rates. Now we'll go ahead and close that down, and let's go over to the channel itself. And here in the channel, we can see that the data rates are more detailed, a lot more individual data rates being reported here. And on packet types, if I collapse my control and management frames, you can see the retries right there. It's up closer to 1% of actual retries. And that's because we're now dealing with other devices that are communicating on this same channel. So there are other networks. If we go back to our nodes down here, you can see that there are 1, 2, 3, 4, 5 networks that it sees down here, and up here we see 1, 2, 3, 4, 5. Actually, I guess it's 6 total networks. So there are 6 networks that are operating on that channel, and I'm going to be capturing frames from those other networks as well. And in this case, that's what's shooting up the retry rate. Some of their networks aren't working as well as mine because, well, maybe, just maybe, they're not in the room with their access point, and that's going to impact that as well. Now, I do want to point out one quick thing here, and that is, see if I can find it right here. Notice in the channel I'm detecting 3,800 and some CRC errors. Well, don't let that concern you too much. You'd have to look at the frames that have the CRC errors. If they're not in my Office 5 network, it's probably not a problem. That CRC error is reported by my local adapter that's capturing this information, okay? And my local adapter is trying to decode frames that are sent at a data rate good for the station and AP that are actually talking, but not good for my client, which may be very far away from that particular station or AP. And so for that reason, you have to keep in mind that CRC errors are not necessarily relevant just to your basic service set that you're analyzing, but any other frames it's also seeing are key to the CRC errors. So this gives you just an overview of some of the things that you can do in a protocol analyzer and some of the things that you can see very quickly. We fail to have time today to go into all of the extensive details, but just from this alone, you're already seeing some useful information. By the way, if you go to latest IP connections when you're dealing with encrypted Wi-Fi, you're not going to see any because everything above layer 2 is encrypted, right? In the actual MSDU, the MAC Service Data Unit, gets encrypted to create the MPDU, which is actually transmitted. So what we're encrypting is layer 3 and higher. And because of that, we don't actually see it when we capture these 802.11 frames. If I had the key, I could enter the key, and then I would be able to get that information. I do happen to know the key, but for sake of time, we'll not bother to do that today. You can see when I go to packets, this is where, as we saw before, I'm actually looking at the individual packets. And so when I'm looking at this packet, I scroll down and see my SSID. This is a perfect example. So here's the SSID. That's not my network. That's not Office 5. And so it's one of the other networks that's out there. And if this one happened to have a CRC error, it wouldn't automatically mean that it's a problem for me. Let's stop the capture here and take a look right here. Notice this says this is a damaged frame. But when we look at the signal level, the signal's neg 78, and yet it's 72 megabits per second. When we take a look at it, you can see that it's a type 2, which is data, subtype 8, which is quality of service data. But the basic point is it's saying something's not here. I wasn't able to capture this full frame. And that again is because it's not for me. It's for another network, and my signal strength may not be good enough to decode the entire frame when it kicks in at the highest data rate to send the actual MPDU. So it's important to keep that in mind when you're looking at packets and you're seeing errors in the packets. If they're not from your SSID, if they're not from your network, then it's not necessarily a problem that it's corrupted. It might not be if you move closer to that actual network. Okay, let's close CommView for Wi-Fi. Now the next thing we want to do, as I said, is take a look at some command prompt commands that are very useful for troubleshooting. And this won't take us very long, but we do want to take a look at a few of these. The first command I want to show you for troubleshooting is probably one of the least known commands in the Windows command line interface. And most people have used or have heard of ping, but fewer have used PATHPING. PATHPING is a command that allows you to combine traceroute and ping together with statistical analysis. So what it's going to do is it's going to do something like traceroute and show you all the hops along the route to a destination, but it's also going to ping each hop a certain number of times to look for lost packets. So I'm going to do it using the internet, but using your local network, you can use this for troubleshooting and analysis as well. If I say PATHPING, for example, cwmp.com, and then I'm going to say -P50 and -Q50. And what that means is I'm going to wait 50 milliseconds between pings, and I'm going to send 50 pings to each hop. That's less than the default, and so it will process it faster. So I'm going to go ahead and run through this, and we can already see that it's found the local computer and the local Linksys router, and then it's going to go find the rest of the routes. It'll take it just a few seconds to run, and then what we're going to do is see when it's done, it's computing statistics, it says, for 40 seconds. Well, the reason for that length of time is I have limited it to 40 milliseconds between pings and 40 queries at each hop. If you use the default, it's going to run for more like 250, 260 milliseconds, or rather seconds. In this case, with the number of hops on the route, the more hops, the longer the statistical gathering takes. But when you're done, what it's going to do is show you how many, if any, lost pings, or in other words, how many times did I not get an ICMP echo reply from the actual device. So we're looking at lost packets there. And it's going to let me know that. It's also going to let me know round trip times for each one in milliseconds. So it's some useful statistical information, but also helps you analyze when you're having problems along the route to a destination or something like this. So we're starting to get the results in now. We're seeing that we're 0 out of 100, and so we had 0 loss all along the way in this case. So really good trace results, but PATHPING is a useful command. Of course, you already know about ipconfig. We'll just run it here briefly. This is a common command used to show you your IP address so that you can work with that. Of course, ipconfig/all is helpful. You also have another command that, again, is seldom used, and I want to spend a little bit of time showing you that, and that is the NETSH command. The NETSH command it's actually a shell interface, and let's change our settings here just a bit to make this a little easier for you to see. That's not very pretty. Let's try a different setting. There we go. So that makes it a little bit larger and a little easier to see. And so what we're looking at here is a command shell. I'm in the network shell right now. If you just hit question mark, it'll show you the help, much like working with a Cisco iOS interface or something like that. And what I want to focus on here today for just a couple of minutes is what you can see about wireless LAN information. So if I type WLAN and then question mark, you can see that down here at the bottom are the unique commands in this context: add, connect, delete, disconnect, dump, export, help, refresh, report issues, set, show, start, and stop. So you can set configuration information here, but what I find most helpful is the show command set. So if you say show ? You can see that you can look at drivers, for example. If I say show drivers, it will show me information about the drivers. It's telling me that it's an Edimax AC1200 adapter, that it is pulling information and drivers from the RTW LAN U sys and V Wi-Fi bus sys drivers. I can see the radio types supported are 11AC, N, B, G, and A. The duplicate N is because of 2.4 and 5 gigahertz. I can see that management frame protection is supported. I can see the different security that is available as well. So that's useful information. I can also take a look at my networks. If I say show networks, I will see the networks that we were seeing in CommView for Wi-Fi. It'll display those for me. And if I say show networks mode equals BSS ID, then I'll get more detail for each network. So for example, notice I'm seeing 46% signal strength on this particular network, and I can see the data rates in the channel that it's actually running on. So I get a little bit more information when I go into the BSS ID mode. I can also use a show interfaces command, and this shows me my Wi-Fi interface. It says it's disconnected right now. Let's just go ahead and connect and see what difference that makes. So it's now connected, and let's run the same command again. And now you can see that it's showing me I've got a great signal, 100%. My maximum data rate is 867 megabits per second. It's actually 866 point some, but it rounds it up. I'm on channel 149, and I can see that as well. I'm using WPA2 personal, and it's 802.11ac, which of course is obvious by the data rates at this point in history. So that's useful. If I say show profiles, from here, I can actually see all the profiles that are there. There's only one, the Office 5 profile. So I can actually see that profile is available for all users. And if you say show profiles, ? You can see if there's any extra options. And of course, there is here the option of the name of the profile. So if I say show profiles, name equals Office 5, then you'll see more information about it. So you can see some information about costing if that's been configured, security settings, and the information about the SSID name and the network type and so forth. So this is some useful information. Again, a lot of people are not even aware that this is available to them at the command prompt using NetSH. And with that, we're going to go to one more piece of information, and that has to do with the Network and Sharing Center. And when you click on your Wi-Fi link, what you'll notice is it does show your data rate here. And if you go to wireless properties, not anything here but configuration, right? If you go to details, you're going to see your IP settings, but nothing really about wireless. Here's a trick. If you click diagnose, let it run, and then click view detailed information. This is where you can get some great information about your wireless link. So if I go into my detection details, first of all, I can see it's my Edimax and the driver that it's actually utilizing. Notice this though, if I scroll on down, I can actually see the BSSs, and there it is, the missing information that people always say, I wish you could see this in Windows without having to add a special tool. Right there it is. So Office 5 is at neg 44, Rich 5G is at neg 41, and so we can actually see the signal strength for these different BSSs that are being detected. You can also come down and see the information about auto configuration and whether they're compatible or not. You can see the preferred networks. Office 5 is preferred in my connection. Here's my Office 5 actual connection and a whole lot of information about that connection and the details there, such as the last AP MAC address to which I connected with that SSID. I can see my packet statistics for that SSID, and then under the rest of the information, mostly just summary data. There's a log as well for these network statistics that's available to you. I'll go ahead and click on cancel in this case, but I always like to show people that little tidbit of extra helpful information that's available that many people are not aware of.